you can skip. That's fantastic. So anyway, yeah, right. That's what I was doing. C programming language. Why is it decent? Well, there are actually many reasons. Where will I start? First of all, the entry to our program, which is the int main or the void main. The difference is kind of crucial here. I should start with that. Because see, many people use a void main when starting the program, which is a bit incorrect. Yes, you can use void main if you want, but the truth is the return value of the program is important. That lets the operating system know if the program is executed correctly or incorrectly, and you can just add your own stuff. Obviously the default is return of 0 means no errors, that's pretty obvious, but if you want you can change it, you can make your own standard for it. Now return 0 should be there, should very much be there, because that's kind of integrated into all the terminals, command lines, then programs know that the program is executed correctly, it's convenient. But you can make your own miracles, which is I often do that. For example, a real formula program, 1 means out of memory, or a general error, then 2 to 100 are just like basic errors, which means errors due to resources management, and then from 100 up to 1,000, those are like more specific to program errors, and 1,000 up, those are specific to the add-ons. And that's usually enough numbers, yet there aren't actually that much errors. Only the really complex programs require a lot of error tracking. For the rest, error tracking is important obviously, but you'll be surprised how few errors there are. Because let's be real, for example, stack corruption and was the more general error with memory. Unable to access, those aren't that much different for the user because both are just memory errors and both can be set as 1, stuff like that. That's the entry of a program. Obviously in the main we have the argc, argv, but I don't really use that. I don't really see that much of a... I know it will be important, and it is very important, trust me, but argc, argv are kind of optional, and usually when creating more complex programs you have some more sophisticated inputs than just simple argv, argc. So I'll leave that for another time. I haven't actually programmed in C in like 4 months or 5, so this actually tells you how it's like riding a bike. Once you study C, you actually understand how everything works. Now, next thing would be, well, I suppose printfs and print. We could go standard IO later on. We should first look at the actual basics. So first data types, right? We have the char, short, int, and long. All of those very similar. Obviously char has 1 byte, short has 2 bytes, int has 4, and long has 8. There's also void, which is mostly used for pointers, because void pointer means there's... Actually, all pointers are the same. That's what I really like about this, because pointer actually just tells you that this value points to an address in memory, right? And because of that, addresses in memory on newest standard they have 8 bytes. One memory address has 8 bytes, and you can really simply see why this would be useful, because 8 bytes gives us 2 to the 64th, right? 8 times 64th power, I think, or 64 minus, no, not minus 1. No, 2 to the 64 minus 1, I think. I know, my math is a bit rusty. But 2 to the 64 minus 1, there's a same, because it will be similar number of addresses, and you can see that when it comes to the RAM, if you were to short it to only 2 to the 4 bytes, which would be 4 times 8, which would be 32, then the reduction would be massive, and we wouldn't actually be able to get these numbers of RAM that we have currently. So yeah, that's pretty important. But the point is that all addresses have 8 bytes, no matter how big they are. So address for a char value, right, has 8 bytes, just like an address for an int value has 8 bytes, or for a long value has 8 bytes. That's why all the pointers are the same. Even though they have different names for them, are just a suggestion for cleaner programming, but for all, if you want, you can use a void pointer. It's a pain, I wouldn't recommend, because later on you get lost into whatever it means, right? And then you have to offset them manually. What does it mean? Well, if you have an array of chars, for example, if you want to access the 7th char, all you have to do is just the name of the array, square bracket, then 6, because the 7th char, right? 0, 0, 1, 2, 3, 4, 5, 6, 7th char, and then close bracket. That's how you get the 7th char. If you use void pointers, though, the way you have to do it, if I remember correctly, it is the asterisk, so the pointer, right? Then open bracket, char, pointer, close bracket, open bracket, the name of your array, plus 7, close bracket. That's how you get the 7 value. If you go through it, it actually makes sense, because first on beginning pointer to let the program know that we are pointing to this value, then we have the inside the char pointer to let the program know that it is the char pointer, right? So to change its type from the void pointer to the char pointer, right? To let it know there's a char that we are pointing to, and then the name of the array, which is actually in this case not an array, it is the number representing the memory, right? The actual address in memory. So the address number plus 7 tells the program that this number offsetted by 7, actually plus 6. Oh, I'm sorry, I misled you there, but plus 6, obviously, starting from 0. That's why, by the way, programs start from 0, because plus 0 would suggest this exact address. So yeah, that's just how it is. So yeah, void pointers, that's how those things work. Obviously, you can use any pointer for anything. For example, if you would like to break up an integer into 4 different chars, the way you can do it is you can just take the address of this integer with the n sign, assign it to some value, and then use that value as an array, as a char array, basically. So you can do char asterisks name of your array is equal to and the name of your int. And there we go. So you just broke up an int into 4 different chars. What's very important to remember is that allocation, right, malloc, that is standard lib, if I'm not mistaken, standard lib.h. If you'd like to use allocation, you would need to include standard lib.h. That's very important because obviously this is not C++, I'm based in C++, it works a bit differently, but I may be wrong there. But the point is, in C you need to mallocate stuff. So if you'd like to have a char array with, let's say, 16 different char values, then the way you have to do it is you have to do either, if you want it to be constant, then you do char, name of your array, and in square brackets 16, let's know that 16 stuff in your array. Or if you want it to be more dynamic and generally better, although a bit slower, it's more often mentioned because you actually need to use a function, then you have to do char asterisks, so a pointer, name of your array is equal to malloc, right, memory allocation, and in brackets 16 semicolon to end the line. Now, really often compilers will scream at you then because you are switching from void pointer to char pointer, but as I told you already, these are kind of the same thing. Char pointer and void pointer both are just a long value, right? Just 8 bytes. So these compilers won't be giving you errors, they will be giving you warnings. The way you can fix those warnings is really simple. Before the malloc, you can just change the type by giving it brackets and telling char pointer in those brackets. Rather simple. Now, why should you use malloc? Well, because when it comes to this 16 long array, right, that is a bit tricky. You can only have 16, and when it comes to this malloc array, you can then use realloc, which is a very convenient function. It will turn your 16 long array into any array you would like. Obviously, remember at the end to add free and the name of your array in this function to free up the memory for the system, because that's memory is shared, RAM is shared, very important to remember. Now, what else is there? Oh, printf, snprintf, very important for the outputs of your program because they basically tell the user very often something when you are using the terminal. If you are using graphic stuff, then Vulkan would be my recommendation. A great graphics library, well, not really graphics library, I suppose. Vulkan is more of its own programming language. It's so massive. But it's also a bit tricky to use GLFW or SDL for the win. Yeah, it's a bit tricky, although you can, if you want, just download my engine. It has a lot of memory corruption errors, a lot. Well, I suppose I think I found 3, but that's very important. I didn't find them in the code, I found them with results, because I've been testing my engine a lot, and I found basically that there are 3 different errors, 2 which are causing memory corruption, and 1 which is trying to get a value not assigned to the program. Finding them will be difficult, and for that I would need a separate thing, so I'm not going to fix that, at least yet. Unless I find these bugs, somehow I'm not going to fix the engine, which was pretty fine. Now, why is C decent, by the way? Because so far I just did a little introduction, very basic one, to the C programming language, and C is decent actually because everything is built on C. Every programming language almost, except for a couple minor, couple outstanders, assembly obviously, and a couple others. But yeah, because of that, C is basically the root of all programming languages. Then the second reason is that C is very direct. You see, when you tell C something, when you code something in C, then it means exactly what you think it means. That's like a direct translation. For example, I remember once I had this snippet of code which I had to repeat 3 times, but they always had the same value. So copying it and pasting it 3 times would mean that I would have 3 variables with the same name, and that would be a problem. So what I did instead is I put them inside curly brackets, like curly brackets for an if or a for loop. Except I didn't add an if or a for loop. I just added only the curly brackets, and that caused the program to actually respond correctly and not have the problem with these 3 variables which had the same name. And that's because those curly brackets mean that I forgot the name of it now. I really haven't done anything in C for quite a while. But ifs and false, by the way, I should probably add. If is true, it's if and open brackets, right? And then curly brackets for your code, and in those normal brackets, you basically put a statement which is true or false, which is kind of baby mode, because in C there is no boolean. There's no boolean, you have to remember, because boolean is 1 bit, and it is impossible to use bits. You can only use bytes. That's why in C it is way more direct, and instead of a boolean, it is just the value. If it is 0, then the statement is false. If it's anything else, then it's true. Which is important to remember because, really often you can read the results, and really often you also don't need to use normal stuff. For example, you can add a pointer inside the if, and that will tell you if the pointer was assigned correctly. Because really often, if it's not assigned correctly, it will get a null value, which is a 0. So that's a very convenient way to check if something was assigned correctly. I call it a safe malloc. Basically, it's a malloc which is a loop, which will loop until the pointer is in null, right? Then it will loop until it is reassigned a normal value for the operating system. Now, next order of business would be DLLs, dynamically loaded libraries, which have a great and kind of obvious thing. See, the structure is... I'm very sorry. We appear to be out of time for episode 1 of Why C is Decent. I guess I'll continue on the next episode. For now, that'll be it. Thank you everyone so much for watching and have a great day. Bye!